Okay, so you put a dot at 2, -5. So let's erase mine. 2, 1, 2, 3, 4, 5. 2, -5. The slope was -7, yes? Slope is rise over run. So how do I count? -7 is really -7 over 1, isn't it? So I have to either go down 7 to get a -7 and then +1. Or was it +7? I can't remember. It's +7. I know the screen is blue. Don't bother. So it's +7. So I need to have the same direction. I either have to go up and right or down and left. Right? Okay, so up 1, 2, 3, 4, 5, 6, 7, and over 1. Up 7, that way 1. 7 divided by 1 is 7. Or I could have gone down 7, but that would have taken me off the graph. And over 1. I don't know what else I can do. It's counting. Choose a point and count from it. Count up or down first and then left or right. Rise over run. Rise. Rise from your seat. I'm asking you to do this. Rise from your seat. What direction did your head go? Up. Okay. Now, if I ask you to start running somewhere, where will you'll go sideways? Is that good? Okay. Does everybody have it?
Yeah.
Everybody?
Yeah.
I think you're liars. I'm going to make you do one more.
Okay.
On this graph, somewhere, I don't care where, give me a slope of -3 over 2. I don't care where you put it. So once again, choose any point on the graph, and then do rise and run of -3/2, and then put another dot on the graph. I'm going to put mine right there. -3 over 2 means I either have to go down 1, 2, 3 and right 1, 2, or up 1, 2, 3 and left 1, 2. And you will notice that whichever way I do it, I still get a straight line. Can everybody do this? Excellent. Now, let's move away from the random ones. Now I'm going to force you to go to points on the graph. Where is -5, -3? I'm going to zoom in on this to make it bigger. Bottom left quadrant. How do I get there, Zach? Left 5, 1, 2, 3, 4, 5, and then where? Down 1, 2, 3. Everybody agree? Okay, where's the second point going? Where's 2, 1? Okay, how do I get there? Right 2 and up 1. Now I want that slope. How do I find it? You count. Does it matter which one I start at? No. If I start at the second one, I have to go down 1, 2, 3, 4. -4. And then I go left 1, 2, 3, 4, 5, 6, 7. -7. -4 over -7. 2 negatives make a positive. The slope is 4/7. Can everybody do it?
Yes.
Great. Now with the another color, we'll make it I don't know, light blue. 0, -4. 1, 2, 3, 4, right there. 0, 3. 1, 2, 3. There's my line. How far did I go up? From -3 to 4 is how far? 7. Positive. How far did I go left and right? Nowhere. Is dividing by 0 possible? No, the answer is infinity. So this is our undefined slope. Because it's not a slope, is it? Can I ski that? No, that's falling. Everybody understand? Everyone's cool?
Yeah.
Okay. If it's on a graph, how do you find slope?
You count.
You count between any 2 points. What if you started in the middle here between those 2 points? Would that be very easy to do?
No.
No. Try to find points where it actually hits and has a point. Is everybody good?
Yeah.
Awesome. So you can now put a slope on a graph anywhere you want. You can now find the slope if I tell you where to go. Is everybody cool? All right, go to the next page, and we're going to change something again. Is this on a graph right now?
No.
No. Could you put it on a graph?
Yeah.
Yes, that would be perfectly legitimate. You could draw a graph, we could put it on there, right?
Yeah.
But that's a lot of work.
Yeah.
Watch. Don't do this, just watch. I'm going to put this on the graph, I'm sketching it. 2, 7. Everyone agree? 2, 7. And we'll put a pink dot at -6, -1. Everyone agree? Now that that's on the graph, I could count that and count that, couldn't I? But I don't need to do that, do I? Because I'm an intelligent person and I can see to myself, and because Myers told me, if you were going to count from 7 to 1 on the y's, you would go down 7, and that would be -6, wouldn't it? Right? If I added on the graph, I'd have a point here at 2, 7 and a point here at -6, 1, right? And I got to to find the slope, I got to make this triangle, don't I? How far is this? Without counting, you know it's 6, isn't it? Because you were at 7, then you're at 1. What's the difference? 6. And you know you were at -6 here, and here was 2. What's the difference? 8. Everybody with me? So we don't need to put it on a graph. We can also do the other thing, and I showed you this on the very first day we were doing slope. I'll show you it again. We also know that slope equals the change in y over the change in x. Because a rise is how far we go on the y-axis, yes? And a run is how far we go on the x-axis. So what math finds us difference? Subtraction. So if we have a y value and we subtract the second y value, and we have an x value and we subtract the second x value, does that get me the differences of both of those? Now, who decides which is y2 and which is y1? You do. Okay? Everybody put y2 above one of the y values. I don't care which one. Everybody do it. Has everybody done it? I'm going to put my y2 here. Some of you will have put your y2 there. Some of you will have put it here. Don't change it if you don't have what I have. If this is y2, what does that make this? x2. So what does that make this? x1. And what does that make this? y1. Now, fill out this formula whichever way you wrote it. So for me, it's going to be 7 minus 1. Because y2 was 7, y1 was 1. Over x2, 2, minus, and what's x1? -6. What is 7 minus 1? 6. What is 2 minus -6? +8, which then I simplify to 3/4. Now, if you went the other way, you will get the exact same answer, won't you? Which I will do in green. If you went the other way, then you have 1 minus 7 over -6 minus 2, correct? 1 minus 7 is -6. -6 minus 2 is -8. 2 negatives make a positive. 6 over 8 makes 3/4. Does everybody understand this? It's the same as if we counted, but we don't have to go through the hassle of graphing it. Everybody good? Try it with the next one. Go. Decide on your y2s and y1s, plug them into the formula, and see what you get. I'm going to reverse this time, and I'm going to make this guy x1 and y1, x2 and y2. Is everybody good? So far to do slope, you've learned two things. Or have you? How do we find slope? The first way, we counted. When did we learn to count? Right. Okay, Mr. Myers, stop it. Don't be that way. There's more to it than that. You showed us this way to learn slope. What did we have to do this one? Subtraction. When did we learn that? So, was there anything new today? If you can count and you can subtract, can you find slope? How important is slope? Super important. And all you have to do to find it is count or subtract. Everybody good? All right. So, you guys go to the next one. Are these on a graph? So, can we count? Okay. Would it make sense for A to count from that point to that point? Yes or no? Why not, Zach? They're not exact, are they? We can't count that. I have no idea what those coordinates are. Tell me when I can stop my pen. That's 1 point. I could have stopped there. Tell me when I could stop a second time. Or a third time now. Now, what will give me the best guess for slope? Points that are very close together or points that are further apart? One person says further apart, one person says close together. Further apart, right? The bigger the spread you have, the more accurate it is going to be. So, now I have my 2 points, yes? Are they on the graph? So can I just count? Okay, if I start here, what's my rise? Positive or negative? Positive. How far? 1, 2, 3, 4, 5, 6, 7. Then how do I do my run? Left, -2. So what's my slope? -7/2. Can the negative go with the 7? Yes. Can the negative go with the 2? Yes. Could the negative go right in the middle? Yes. Can the negative go with both of them? No. This, and this are all the same thing. Does everyone understand? Awesome. Let's do B. What are the 2 points you're going to use in B? I would use that one and then that one because they're really far apart, right? How do I do the slope? Now, for the red one, I started at the bottom. So for the blue one, I'm going to start at the top to show you that it doesn't matter. I'm going to do my rise first. Is my rise positive or negative? Negative. 1, 2, 3, 4, 5. What's my run? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Positive or negative? Negative. So what's my slope? -5 over -11. Two negatives make what? A positive. Everybody good? Is C 0 or undefined? Undefined. Why? Because it's straight up and down. That's not a slope, that's a fall. What's D? 0, because that's not a slope. You couldn't ski that. If you were on a snowboard, you'd have to do that stupid hoppy thing. all the way along while all the skiers go by you and you feel stupid. You don't. You still think you're cooler than all the skiers, even though you're hopping along like a doofus. I really have never understood that. I don't understand how snowboarders can think they're cooler, but they all do. Everybody good? All right. Try to sketch 4. If it helps, start with a coordinate grid. All 3 sides have to be positive. Yes, of course you can go to the bathroom. Same difference. Both piss me off, so. How many sides does a triangle have? 3. So you got to start with one line, yeah? How do I make a positive slope? It goes up and where? Right. So as long as I start my first line up and right, am I good? Great. Now I need a second line, don't I? How does it have to go? Up and right. So my second line has to start here and go up and right. Is that okay? Did I go up and right? Okay, then the third line would also have to go up and right, wouldn't it? So from here to there, is that up and right? Easy peasy lemon squeezy.
From that point you went.
This line is up and right, positive, positive. This line is up and right, positive, positive. This line is down, negative, and left, negative. 2 negatives make a positive. Is everybody good? Everybody understands? Positive slopes lean to the right. Negative slopes lean to the left. Because negatives are to the left and positives are to the right. Does everybody get it? Awesome. Possums. Now, put together the last 2 lessons. 3x minus 2y plus 8 equals 0. And I want the x and y intercepts. What do I know about x and y intercepts? What is every single x-intercept? X, 0. What is every single y-intercept?
0y.
0y. Those values are x values and y values, right? What do you see right there and there? X values and y values. The first one. X is x. What letter is that?
Well, x.
X. What do I put there? X, because x is x. 3x. Minus. Y is what? 2 times 0 plus 8 equals 0. 2 times 0 is what? 0. So when I'm looking for an x-intercept, can I just throw out the y? Can't I? Because it's going to be 0, isn't it? So when I want an x-intercept, I only care about the x value. 3x plus 8 equals 0. Do I have an x value yet? No. What do I got to do to find an x value? Algebra. Minus 8 from both sides. 3x equals negative 8. What does x equal? Negative 8/3. Should I put that on the graph right now? No, why not, Gio? It's ugly, right? It's a fraction. I don't want to put it on here because 8/3 is hard to find. What am I going to do for this one? If when I'm looking for an x-intercept, I can throw out the y. Now I'm looking for a y-intercept. What do I get to throw out? The x. So negative 2y plus 8 equals 0. Negative 2y equals negative 8. Y equals what? Positive 4. Now I can start thinking about putting them on a graph. What makes the x-intercept a pain in the x? It's a fraction, yeah? Can I make it easier on myself? Sure I can. 1, 2, 3. If I make that negative 1, what is each x square worth? 1/3, right? And how many thirds do I need? 8 of them. So 1, 2, 3, 1, 2, 3, 6, 7, 8. Is everybody cool? Does everybody understand what I just did there? Now, if I want to keep this scale, can I do that on the y-axis? As this graph is right now, can I do it? No, because I would need to go up 12, wouldn't I? And I only have 10 to go up. So I have to keep my y scale normal. I'm going to say that on the y scale, that's 1. Which means how far up do I go? 4. 1, 2, 3, 4. Is everybody cool? Now, I would connect the line. Now, here is where you're all going to make a mistake because you stopped listening a while ago. Is this line on a graph?
Yes.
Which means to find slope, all I have to do is count, right?
Yep.
What's the slope of this line?
There's no point on them.
If you count, do you get the slope?
No.
No, because you go up 1, 2, 3, 4, positive 4, and then you go this way, 8, right?
Yeah.
You go 8 squares. So the slope should be 1/2, shouldn't it? But it's not, because you didn't really go 8 squares. How far did you go this way? 8/3, 2 2/3. Does everybody understand? If you change your scale and I need to know the slope, you don't get to count anymore. Does everybody understand? Remember, this is exactly like what we did when we were doing speed, right? When we went up 30 and over 2, right? We didn't go up 30 squares, did we? We went up 30 numbers. Is everybody good with that? Everybody cool? Or do you need to see that example to prove to yourselves that you already know what I just showed you? I'm going to show you anyway because I think you're all liars. That was 5 golden rings. Remember here when we did this, right? We went up. We didn't go up. We only went up 1, 2, 3, 4, 5, 6 squares, right? But we went up a value of 12. And we went out 2 squares, but that was a value of 4. So our slope was 12 divided by 4 to get 3 meters per minute. Everybody remembers that, yes? And you already knew it. Well, here it is again. Everybody good? All right. Okay. This question can be completed in 2 ways. It can be completed graphically, and it can be completed algebraically. Which do you want to do first? Algebraic? Okay. Since I have 2 points and a slope, slope equals y2 minus y1 over x2 minus x1, correct? Okay. What's this guy, x2 or x1? It doesn't matter, does it, Hannah? You want to make that guy x2. That's cool. So what does that make this guy? y2. What does that make this guy? x1. What does that make this guy? y1. And what does that make the 2? m. Do I now have everything I need to fill this in? Great. What do I put in for m? 2. What's y2? 6 minus what's y1? Y over what's x2? 2 minus what's x1? -4. Solve this. 2 equals 6 minus y over what's 2 minus minus 4? 6. How do I solve this? Algebra. What do I do with the 2 and the 6? Cross multiply. What's 2 times 6? 12. What's the number that's really under 2 here? 1. So what do I do here? Cross multiply. What's 1 times 6? Minus 1 times y. Y. Solve this. Six equals negative y, so what does y equal? Everybody cool? Can everybody do that? That's algebra. Now let's do it graphically. Which of these points, A or B, can I put on a graph right now? A. Somebody take me there. 2 to the right and 1, 2, 3, 4, 5, 6. Agreed?
Yeah.
Okay. What is the only thing I know about point B?
That the x is -4.
That the x is -4. It has to be somewhere on this -4 line, doesn't it? Everybody agree? And I know my slope is 2, yes? So, to keep my slope positive, I have to go down to right 1, correct? Am I at this line yet? So I got to keep going. Down to right 1. Am I at this line yet? Down to right 1. Not there yet? Down to right 1. Still not there? Down to right 1. Still not there? Down to right 1. Now I'm there. And look at what the value is. -1, 2, 3, 4, 5, 6. Can everybody do this algebraically and graphically? Yeah? -2, -1. Two negatives make a positive. Is everybody good? Is everybody good?
Yeah.
Prove it. Do 7. Once again, x2, or wait, I'm not going to do that. Do it algebraically and graphically. I don't care which one you start with. If I'm doing it algebraically, what do I have to do to all these points? I got to assign them a value. What do you want to make this one, Ariana?
x1.
x1. So what does that make this one? y1. What does that make this one?
x2.
x2. What does that make this one?
y2.
y2. What does that make this?
This is the slope.
Which is m. M equals y2 minus y1 over x2 minus x1. How do I fill that in? What do I put in for m? -3 over 2 equals, what's y2?
-4.
-4 minus, what's y1?
5.
5 over, what's x2? X minus, what's x1?
-1.
-1. Solve this. What's -4 minus 5? -9. What's x minus minus 1? X plus 1. What do I do whenever I see fraction equals fraction? Cross multiply. What's -3 times x plus 1? -3x minus 1? Minus 3 equals, what's 2 times -9? Minus 18. Solve this. -3x equals what? Minus 15. What does x equal? +5. Right? Yes, of course you can. You'll get the same answer. Oh, can I actually do that? Yeah, okay. We'll change color to, let's go with light green. So you have -3 over 2, and you've reversed this order. So you have, this guy is x2, y2, x1, y1. So that becomes 5 minus 4 over -1 minus x, right? -3 over 2 equals 9 over -1 minus x. -3 times -1 is +3. -3 times -x is +3x. 2 times 9 is 18. 3x equals 15. X equals 5. Okay? Now, on a graph, what's the point I know? -1, 1, 2, 3, 4, 5. Correct? And what's the only thing I know about this other side?
It's the y is -4.
The y has to be at -4, correct? So all I got to do is get down to that line with a negative slope. So down 1, 2, 3, right 2. Am I at my line yet? Nope. Down 3, 1, 2, 3, right 2. Am I at my line yet? No. Down 1, 2, 3, right 1, 2. Am I at my line now? Yes. And what is that x value? 1, 2, 3, 4, 5. Can everybody do it? Yeah?
Yeah.
Excellent. Now, prove it on 8 and 9. Then there's a bunch of practice. Now listen to me and listen to me closely. If you get a couple of these, and remember, to get it, that means you can do the last couple. If you do the first couple and you're like, yeah, I got this, no problem, try the last two. What's important to me, because you have the answers there, is page 198. All right? Now, before you start on 196 and 198, I left 2 blanks here, yes? What should you try first? These 2 blanks, number 8 and number 9. All right? Today was a little bit of a long lesson, so I'm not doing 2 like I said I was going to do. But over the next couple of days, I'm going to be doing 2 of these a day. Okay? Because by now, you should all be very comfortable with slope. And slope is the basis of this whole unit. Everybody cool? So you try these 2 right now, by yourself with your neighbor. I don't care. I'm going to fill them both in right now the way I would do them. Then you're going to check your work. All right? Now notice, did I say you had to do it graphically or algebraically? No, I don't care which way you do it. I want to know at the bottom of this space what x equals. You figure out how to do it. Then, if you did number 8 graphically, what should you do for 9? Algebraically. If you did 8 algebraically, what should you do for 9? Graphically. Everybody good? I, of course, am going to do both for both. And I'm going to do the algebra with both x, y, 2's. Everybody good? Go. Okay. I have them both done. Most of you should have the first one done, yeah? What is your answer for number 8? What is y, or what is x? 4. There it is, the only 3 ways you could have done it. Is everybody good? Is everybody good? Now, if you made an error, I just heard at the front, oh, it's 12, because you screwed up the 7 and 5, right? You maybe did 7 minus 5 instead of 7 minus 5. Whatever. Is that doing this concept wrong? Or is that just, I screwed up, sorry. It's just that one, right? Everybody good? Now, the second one was trouble, wasn't it? Because algebraically, it was pretty easy, right? Yeah. What was it algebraically? No. There it is algebraically. Oh, sorry, the second one. Now, why does it confuse you? Because it doesn't work out perfectly. But you follow the process. It's still y minus 2, y minus 1. And at 1, eventually we end up here. 21 equals negative 2y. Or negative 21 equals negative 2y. You still do algebra. The point 11.5 on the y scale exists. Yes. Oh, of course it should have been 10.5. Thank you. 21 divided by 2 is 10.5. What an idiot. Thank you, Ethan. Now, what happened over here if I try to graph it? It didn't work. Why? So I knew it was going to be at negative 1, 2, 3 and down 1, 2, right? And I knew I had to get to here on the x scale, yeah? Okay, so up 1, 2, 3, 4, 5 over 2. 1, 2, 3, 4, 5 over 2. 1, 2, oh, dang it. It's off the graph, which means what must I do? No, I can't go the other way, or I'll still go off the graph. I got to change the scale. I got to make each square worth 2. Now can I do it? Negative 3, negative 2 would be right there, right? Halfway between 2 and 3, or 2 and 4, and at negative 2, yes? And I got to get to this point now. 2. Now I can do it. Up 2, 4, 5 over 2. 1, 3, 5 over 2. 2, 4, 5 over 2. And you can see the line goes through right there. 2, 4, 6, 8, 10 and a bit. Is everybody cool? Now, what way gives me a better answer? Algebra or graphing? Algebra. Everybody good? Why then, Mr. Myers, did you spend so long showing us graphing? Because that shows you how the algebra concept actually works. So you don't have to say, whatever, I'm just going to do it. Okay? Everybody good? All right. Remember, try a bit of 196. The answers are on 197. Make sure you can do 198. Now notice it says practice. Am I marking it? No, but am I going to come around? Yeah.